Hi everyone. Recursion is tricky, and lots of you still haven't yet summited this mountain for yourselves. So let's sort of think back through one more time. How does this recursive terrain generation algorithm work? The goal of the algorithm is to fill the entire two-dimensional array with numbers that correspond to the heights that we want the landscape to have. Well, it might be worth saying at the outset, why do we even need recursion at all? If you're just trying to fill an array full of numbers, why don't you just iterate over it and assign random values? Well, the reason why is because realistic terrains have kind of larger features that connect to each other smoothly, but with some random variation in between. So I might have a peak here and another peak there, and so the height values need to connect to each other, but I want some amount of random variation up and down in between. But in order to retain the large features, the randomness in between has to be smaller than the randomness that generated the large features in the first place. So that's the kind of issue. It's how do you connect the regions randomly, but still maintain the coherence where large features are based on large random values and smaller features are based on smaller random values. So before we start talking about recursive steps and base cases and things like that, let's just understand at a very high conceptual level, kind of one sentence, what's the idea? How do you fill the array full of numbers? Here's the idea. It's a kind of a divide and conquer method. So if we're given an array with 4 corner values that we know, the way that we'll fill in the rest of the values are, we'll divide the array into 4 quadrants, we'll assign numbers to the corners of each of those quadrants. So I'm missing numbers here, 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 and here. So we'll assign numbers to the 4 quadrants. So let's assign some numbers. So like between 2 and 9, we could have 3.5 with a little random variation, so I'll call this 4. Between 2 and 3, we can have, 2.5 with a little random variation, so we'll call this maybe 3.5. Between 3 and 27, we could have maybe 12 with some random variation, so I'll make this one 10. And here between 9 and 27, 18 with some random variation, I'll just make it 18. So, and then we need the center number. The center number can be the average of the 4 corners, which looks like it's approximately 10 with some random variation, so let's make this one 8. Okay, so now that we've taken our 4 corners that we started with, we divide it into regions, we assign the corner values for those regions, and now we repeat. So we'll do the same process for each one of these 4. And if you imagine doing that, that's going to involve dividing each of these into 4 quadrants, filling in the corner values and the center values, and then repeating. So we're going to start big and subdivide and subdivide and subdivide until we're left with a whole bunch of little tiny 2x2 sections throughout the whole array, and that's the base case. Then we'll be done. Okay, so how does this look when I'm not waving my hand so vigorously? Because we need to be able to recursively subdivide this entire array into smaller pieces, our getLandscape method, which is supposed to fill the array full of values, needs not only the array, but it needs some indication of what part of the array are we operating on. Are we trying to fill the whole array, or are we in one of our recursive calls where we're only looking at like one of the quadrants, for example? So that's why we take row 1, column 1, row 2, column 2. There are other ways you could specify the subregions, but I'm thinking row 1, column 1 are the row and column of the upper left-hand corner where you want to be operating, and the row 2, column 2 are the row and column of the lower right-hand corner where you want to be operating. So if the whole concept here is we want to take the entire array and subdivide it into parts so that we can recursively apply the same technique, we're going to need to know what are the row and column, which is the place where we're going to divide it. So don't base your row and columns off of the size of the entire array. Remember, you're always thinking completely in general with this method. So if I make I'll call it MR for mid-row and MC for mid-column. If my mid-row and my mid-column are based on array dot length divided by 2, well, that only makes sense if the region I'm operating on is the whole array. But what happens later on when I run generate landscape and my rows and columns are like somewhere much smaller in here? In that case, my midpoints are going to be in here and not actually half the size of the entire array. So my mid-row and my mid-column are the midpoints between my row 1 and row 2 and midpoints between my column 1 and column 2. For this particular array, it looks like there is no central element that's exactly in the middle. So if I take my row 1 and my row 2, sorry, these are columns. If I take my column 1 and my column 2 and I divide them by 2, it'll be integer division, and this is going to get me my mid-column, and my mid-row is going to be here. Okay, so that puts this as my center element. I'm going to want to have my recursive calls now operate on each of these regions separately. So down here I could say, let's run generate landscape with the same array, only let's do the upper left-hand corner. So I would want it to start at, some people wrote 0, 0, but remember, you're thinking in general. When you're writing your method, you're always assuming that you're going from row 1, column 1 to row 2, column 2. So it would be a mistake for me to write 0, 0 here, because the first time I run get landscape, yes, 0, 0 is the upper left-hand corner. But later on when I run it, it might not be. Row 1, column 1 is how we've defined where the upper left-hand corner is for this method in general. So I'm going to want to run it from row 1, column 1, down to, if this is the upper left, this is the lower right, at mid-row, mid-column. And then we'll talk about the variance later. If I want to so that will now recursively run it on that box. If I want to recursively run it on this box, I'll do generate landscape with the array. Only now, this is my upper left-hand corner, which is row 1, mid-column. And then my lower right-hand corner is down here, which looks like it's mid-row, column 2. So that's the idea. We need to subdivide it and run it recursively. So there's 2 more recursive method calls you'd need here. Okay, but look, we're going to be in trouble if we just go ahead and run a recursive method call, because what we need to do is we need to assign this center number a value. That's the whole point. That's how we're filling the array with numbers. So in order to assign the center point a value, you need to know the heights at the 4 corners. So if you're thinking about my recursive call where I'm going to be operating in just that section, in order to assign the center number, I need to know that one, and I need to know this one, and I need to know this one. I need to know all 4 corners in order to assign the middle one. So what that means, thinking back to our original call where we're thinking about the whole array, every single time I run this method, before I do my recursion, I need to make sure I've filled in the center value and the 4 edge values, because the 4 edge values are going to turn into corner values when I look at a smaller region. So let's fill them in. It was the same thing I did last time. I'm going to average, so for this value, I'm going to average 3 and 20, and then add some small random variation. So that's 11.5 plus a little bit. I'm just going to write numbers. That I'm not going to try very hard to make these accurate. So this is going to be, I don't know, 10, and this is going to be, I don't know, 19. Okay, so now that I filled in 1, 2, 3, 4, oh, and then the center one, of course. Now that I filled in the 5 values, now when I run my recursive call here, I'm saying start there, end there, and I've already filled in numbers for the 4 corners, so when I start over again from the top, now the whole process starts again as if this was all that existed inside the array. So again, I'd calculate where's my mid-row and my mid-column. So now the mid-column's here, the mid-row is here. I'd calculate a value, and I'd put it in the middle here. Let's make it 29. I need to calculate values for these 4 corners, and then I'm going to run it again recursively with that group, this group, and this group. All right, last but not least, we have to think of the base case, because otherwise we're just going to keep looking at smaller and smaller and smaller regions forever. So usually the base case is the smallest example of this method that you can get without having to do recursion. So it's going to be a region where there's nothing left to do, so there's no purpose in doing the recursion. So I'm thinking if we have a 4x4 region, that would count. So for my base case, I'm going to say if the difference between row 1 and row 2 is less than or equal to 1. So if I have a region that's a size 1, or if I have a region that's a size 4, either of those. So if row 2 minus row 1 is less than or equal to 1, I could do the same thing for columns. So if column 2 minus column 1 is less than or equal to 1. If either of those is the case, then I'll just exit because there's nothing left to do. Okay, this is challenging. Even more than regular programming. Recursion, you really have to think about what you're doing. Just typing on the keyboard is not going to help. Like, the whole problem gets solved on paper. I don't know how much I can emphasize this, but I'm seeing a lot of people trying to approach this the way you usually approach programming, which is you sort of think it through about 70% of the way and hope it's all going to resolve itself as you're typing it. These are puzzles that you really have to think out in very clear detail before you ever start. Okay, good luck!